Okay, so for those of you who are done many Think-a-Thons with us, this is going to be old news, but we have to do this each time because we have brand new people each time. So we're going to do this very quickly. For those of you who are brand new and never heard this before, and it's going way too quick, it will be posted later, and you can always catch up and redo this if you need. ScHARe is a cloud platform. Its acronym stands for Science Collaborative for Health Disparities and Artificial Intelligence Bias Reduction. This platform was actually built with underrepresented populations that are not in data science. So we are trying to do these Think-a-Thons and the ScHARe platform for people who have never done data science and have never done cloud computing before. So if you're brand new and you're lost, you're exactly the people we're trying to get to. And we just have to do it in a little systematic way so we can move people along in different speeds. So the platform was actually created by NIMHD, the Office of Data Science Strategy, which is in the Office of the Director of NIH, and in a collaboration with the National Institute of Nursing. We have many people to thank for this effort because it has taken 2 years for us to even get to this point, and we are just beginning. Today's outline, as I said to you, we're going to go over the overview, and then we're going to explain what Python is, and then Cindy Schofield from Office of the Director is going to walk us through the Python for data science. And both Luca and I have taken this course from her before, and she's excellent. So you have a treat. So Kevin, one of the things that we'd like to do is to have you fill out this poll. So Kevin's going to teach you what to do to add a Sligo.
Thanks, Debbie. So like Debbie mentioned, today we are going to be doing a few polls during the presentation, and we're going to do that through something called Slido. So to use Slido, you can either download the Slido app on your phone, or you can simply go to slido.com, again, shown here right on the screen. You can go to slido.com on your phone or your computer, or alternatively, you can simply scan the QR code that you see here on the screen, and it will bring you to today's Slido. So to join today's Slido, either via slido.com or the app, just enter code Python when it prompts you to enter code here. For those of you on slido.com, that will be at the top of the page in the blue box, similar to the one you see here on the slide. Again, either use slido.com. The method I recommend most is just use your mobile device, scan the QR code, and it will pull it right up on your phone.
And also, Mark, would you put it into the chat, please, so they can just click on it in the chat?
Yes, I did that.
Thank you.
Perfect. And so now we will move on to our first poll of the day. So I will pull that up here. Let's go. You should be seeing this here. So once you are on slido.com, again, you can feel free to either use the link that Mark put in the chat or the QR code here. Just feel free to respond to that poll. And once we get enough responses submitted, we will take a look at the results.
I really encourage all of you to help us with these polls. And part of the reason that we do these is because it helps us to understand the level of experience with our users and what you potentially need. And of course, we also are very interested in targeting people who are not currently in the data science field. So some of our next question is going to be more demographic like. And this actually helps us to do a better job. So I'm really asking you to do this as much as possible. Good. Cynthia, I hope you see this. The level of experience with Python.
Yes, yes, that's good. I'm glad. That's exactly our targeted user. Yes, thank
That's
you.
right. So you're going to have fun today.
Hopefully they will too.
Go ahead next, Kevin. A little more with R. Okay, next. Good. Next. I hope that 7% are the people that participated in our other Think-a-Thons. Next. Good, because we're trying to get at health disparities populations too to do research. Next. Okay, next. The bias mitigation part is a little bit down the future. So hopefully this will change soon too. I think that's the last one, right?
Yep, and so we will now move into our second poll.
Okay, good. So it seems like you all have come to the right place, because this is exactly what we're trying to do, is to teach these cloud computing skills to leverage big data and to be able to conduct research, especially focusing on health disparities and health outcomes. So this is great. So we're going to do a little presentation now over what ScHARe is, and it seems like we have some new users here today. So this might be a little more important than I once sometimes think. So ScHARe is a cloud based, like I said, by NIMHD, NINR, and the Office of the Director. It's our three main goals for ScHARe is to increase representation of women and populations with health disparities. We want to help people because many of you on this call, you know that AI is taking off like no tomorrow. And so much of the research is being done now using big data and cloud computing. And we want to be sure that we're not left behind. So all of us that are underrepresented in data science, we need to catch up. And we also need to create this paradigm shift in our thinking, because this is one of the things that we hope to do. Right now, we think of research as, A then B, or, a regression or a description, but we can learn so much more from information because of big data sets. And so we now have to sort of shift our thinking into how do we develop hypotheses and understand for us really what causes things like health disparities or epigenetic studies where we can link genetics with social determinants of health. And of course, the other part that we're always interested in is the bias mitigation, because we're finding that many of the algorithms, no matter the consciousness level of the programmers, are having disparities.
Debbie, I'm not sure we are seeing your slides.
Whoops. Now are you?
Yes,
we
thank
are.
Okay. So ScHARe is made up of multiple components. It has data sets that are really population science-based, including social determinants of health, environmental, behavioral types of data sets. We're building a data repository based on common data elements and federated data sets that can be combined. Of course, like any other cloud, we have many computational abilities, and because of Terra, we have private workspaces. And we have many tools for developing both algorithms and other types of analytics in order to make healthcare and policy decisions. It is a Google platform with a Terra interface. It is connected also with GitHub, and we have access on the NIMHD webpage to the ScHARe portal itself. The ScHARe data ecosystem will combine Google Cloud data sets. These are public data sets that do not have identifiable information. They're often called federated, so it's a new term, federated data sets. One example of the data set that is on there is the American Community Survey. We also have what we call ScHARe hosted data sets, and the ScHARe hosted data sets are national data sets or state or data sets, but they're not hosted by Google, so we pay to host them onto the cloud. And an example of that is the BRFIS system. It's the Behavioral Risk Factor Surveillance System. So data like that is also on there. And then the third part of our ecosystem are funded data sets from grants. And they can be an individual project, or it can be a large study like the Jackson Heart Study. It also includes our intramural data. As you can see to the side, the data sets are categorized by the social determinants of health: economic stability, education, healthcare, neighborhood, social, and community context, with the addition of health behaviors, disease, and conditions. In the data sets, some of the public ScHARe data sets are the census, food access research atlas, medical expenditure panel survey. There's many, many data sets. I think there's now about over 200, and our goal is to have 300. We use many of the same types of computing tools like Python, BigQuery, TensorFlow, Jupyter Notebooks. And the thing that we are working on the most right now, which is going to benefit all of NIH and all of the cloud platforms. One of the reasons it is so difficult for users to use these cloud platforms like all of us, Anvil, Biodata, Catalyst, and even ScHARe, is because big data requires the knowledge of Python or R. But we are working with SAS, which is a statistical program, to actually include it on the cloud as well, so that statistics can also be run in this environment. We work, of course, on mitigating biases and many of the things that we're involved in many different levels, and we're going to go into many specific things during other think-a-thons for bias mitigation. So that was phase one. We're entering in phase two. In phase two, we've developed a core set of common data elements. What that means is that we will be requiring that NIH or NIMHD funded studies use these data set or these common data elements in their data collection in order to create interoperability, data harmonization. This is a very important part of being able to do AI types of analyses, because it requires big data sets, so we have to bring them together. And this also then complies with the NIH policy on data sharing, and it creates a data ecosystem, because not only are we going to be able to cross data sets, we're also going to be able to aggregate across platforms. So what I mean by that is this: when you have a project, if they have the core common data elements, two different projects can be aggregated together and harmonized so that you have a bigger data set over the same particular issue. So as you can see from the many different topics over here, if we can link all of these together, you're going to have an enriched data set that allows you to do more analyses. And the other piece that we're doing is we're taking the core common data elements and we're actually linking them to the federated data sets, so that you're going to be able to bring in these federated data sets to help you better understand what's happening in your project data. And the last portion of this, not the last step, but last thing I'm showing you today, is that this little Terra button right here, that Terra is the interface to all four of these large NIH platforms. Because Terra was used, we're going to be able to link across all four of these platforms. So Anvil is a genetics database. By being able to link ScHARe to Anvil, which we have the social determinants of health, environmental, behavioral data, they're going to be able to link to Anvil for epigenetic studies. If you want to stay updated to what ScHARe is, you go onto the NIMHD webpage, which is right here. You will have all of these slides. Mark can put this in the chat for you. Click on Stay Updated, and you'll get all of our newsletter and updates about when think-a-thons are, when things are posted, where special events are, etc. I think we've already done this poll. I just want to go over, we do these think-a-thons. Next year, this has been so popular that I think we're going to do.
It's too fast.
This is so popular that I think that we're going to end up doing 2 think-a-thons a month. One dealing more with the instructional, meaning Terra, understanding data science in Terra. And then we're very soon, like in the next few months, going to move into research collaboration teams. So we really hope that all of you stay involved and become part of the research teams that we hope to develop. Luca, do you want to take this part, or do you want me to do this part? Are you still registering?
If you want to do it, I'll continue registering people. I'm registering about 150 people. So
Okay.
thank you.
Cynthia, do you want to do this part, or do you want me to?
I can do that, Debbie. No worries.
No,
I
you
can-
go ahead and register. I can do it.
You want me to do this part? I can do it.
Yeah, Cynthia can do it.
This is good. This is a great slide to lay some groundwork. So if you want me to go ahead, I can start this and then move
Okay.
on into the presentation. Okay, great. So this is a really great slide. Thank you for providing it. That just talks about what Python is. It is a computer programming language. It is popular for data science. It offers a lot of different algorithms. For those of you who are familiar with R seems to be more popular for visualizations, but data science seems to be gravitating for those who are looking to develop artificial intelligence tools or more complex algorithms, if you will. It will allow you to manipulate and analyze your data and conduct those statistical calculations, and we'll do some of those in just a few minutes. So you'll get to be able to, have some hands-on experience with that. It will create visualizations, and we'll play with those as well. I think that's the beauty of both R and Python is you can take that raw data and revisualize it depending upon the story that you want to tell at that particular moment. And then again, that machine learning algorithm, my interest has always been text mining. And then I learned that you needed machine learning to do text mining. And so that was my motivation at first in starting to learn Python and coding languages again. NumPy is a library that will be importing in a few moments and using that for linear algebraic equations and again high-level math functions. What's nice about NumPy is you simply type like a simple command, install, and then you need to know what it's doing and what you're trying to do with it, but it does the work. It does all of the heavy lifting. Pandas is mainly a library in Python that you bring in to load up your data frame or your Excel file, if you will, to handle all of your data structures and tables within Python. And we'll be looking at that one as well. And I'll talk about an example that a classmate of mine used in my intro to Python last summer. So, and then SciPy again is more for data science skills. I haven't used that one as much. And then scikit-learn, that is on my radar. It's not the very next thing I plan to learn, but it's high up on the list for machine learning. And again, useful for classification, regression, and clustering algorithms. So again, it depends upon what you want to do with your data. And then you just need to make sure your data is clean and configure it and put these tools to work. And then PyBrain, which I'm not covering today, but again, that's also for machine learning tasks. So maybe Luca might be able to comment on that later on in the session after he has finished registering everyone.
So let me just add, one of the important things about these libraries is that they're already set up for you. So all you have to do is go in, like Cynthia said, and hit install or run. And so it makes it's a great source to start coding. And she's going to cover a few of these today, as she said. And that's different than R. R is a programming language for statistical computing, but they also work on big data. On the ScHARe platform, there are R packages as well. So as many tutorials that we have in Python, there's also R, and on the Terra platform is RStudio. We're not encouraging it because Python is the main language that is used. So everything that we're going to do today and focus on is going to be on Python. Do you want to take this back over, Cynthia, or do you want me to do this?
Sure. And I'll go ahead and start my video as well. Just wanted to say hello to everyone and thank you for having me today. I'll go ahead and I guess share my slides or my screen.
Well, let me finish this slide then.
Sure.
We'll move years.
Okay.
This is what I was saying about why we are advocating for people to learn Python, is because most of the machine learning is done by Python programmers. R can work, So we're not saying don't learn R or forget R, but I took courses in both. And I can tell you, just like in other programming language, if you learned R, Python's going to be easy to learn. Because anytime you do that kind of coding, it's so similar. And one of the things that Cynthia is going to show you today is sort of the basics of it. And this is what she's going to cover today is going to make learning Python in the course so much easier for you. Of course, depending who you are, how long it will take to learn it and to be able to write your first programs. I can also tell you that more and more libraries are getting created. And on the ScHARe platform, for many of you who've been part of our instructions, we have had several notebooks that already have Python code for you, so that all you have to do is cut and paste to make it easier for you. And there's lots of free resources to learn. So our guest speaker today, as you've heard her, I'm going to turn the program over to her now as Luca continues to register people. And when she gets to a point before we actually do hands-on, we'll stop and Luca will go through all those instructions to get the other users caught up in order to do the hands-on. So right now you can I'll stop sharing.
Okay, all right, thanks. Thank you, Deborah. Thank you for the opportunity to be here. This is a great environment. It's a great sandbox for everybody to learn how to code a little bit. As I mentioned, I just started learning how to code in Python last summer. My motivation was to help others learn how to code in Python. As Deborah was talking about what a great sandbox this is in all of the different sets, like the All of Us data and the Anvil data. Just last week, I had the opportunity to listen to a lecture hosted by NIDDK, and it featured one of my mentors from Johns Hopkins, Harold Lehman, who was talking about how difficult it can be to crosswalk different data sets across each other. So in your journey, you're going to learn how to do things like that so that you can figure out these really big, hard problems. 20 years ago, Harold Lehman would invite guest lectures in, and we talk about this being the future vision. Well, here we are 20 years later in the future. And so this is actually happening with all of you just putting forth the effort to learn something new, to learn a new skill, to be able to make science better. So thank you all for being here and being willing to learn. I'm delighted to share what I've learned in Python. And again, my motivation is I think this is a great way to plan, capture, organize, analyze, and disseminate your future science. I'm happy to support emerging scientists and existing scientists in learning Python as you learn your way to work in your environments. My thought and my hope is that improved documentation within that scientific process will lead to improved rigor and reproducibility in scientific information. And thus, it'll help us all improve discovery. You may know that Python programming originated in the 1980s in the Netherlands, but you may not know it was named after Mighty Python series, The Flying Circus. And so this session will provide you a high-level overview of really just the basics in Python code. It will cover several foundational components of coding so that you'll have a better understanding of what you'll need to learn and then how to approach that learning that's comfortable for you while you take on and learning a new program language. And you'll also know why you need to learn different things in Python code. You need to have that to be motivated to learn, right? The class is designed for individuals who are interested.
I'm so sorry for interrupting you. I'm not sure we are seeing the slides advance.
Oh, so actually I'm still in my intro, but thank you.
Oh, I'm so sorry.
Thank
Okay.
you. That's okay. Anyway, so again, it's designed for those who are interested in coding, but have not coded before. So I'm glad to see that we've hit that target audience. And I'll do my best to identify technical terms as we move through. But if you have questions, feel free to throw them in the chat. And if somebody can shout them out to me, and as you see them in the chat, that would be helpful. I'd be glad to go back over anything that I haven't explained fully. So. So let's go ahead and proceed with the didactic portion, and then we'll get to the hands-on. So why learn Python? It is an object-oriented open source programming language. It is freely available and it runs on most operating systems. It's powerful for analyzing and visualizing data, as we said, and it can be used with Markdown, and we'll look at that in our code as well. So Markdown is a lightweight markup language used to produce human readable documents. You can use it in R or Python or other languages like Julia. Python can help your documentation, help you document your experiments in a way that you can reuse sections of your code. Instead of having to rewrite, all you have to do is kind of like take a part out and put a part back in and rerun your experiment or your data. And see those results. So it's beautiful in that way. It can also help you expedite your documentation as you prepare to present or publish your research. So during this session, we'll be using Terra, as Deborah and Luca has said, and we'll have a brief tour of some of the fundamentals of Python code for reading and writing and running that code. I'll also show you the 4 interactive development environments for writing, compiling, and saving Python code outside of Terra. We'll just look at them briefly, just in case perhaps you can't get to Terra for some reason. You're doing something else different. You're playing with code for a different purpose, maybe. And so the different IDEs or interactive development environments, again, you can take a script and then simply just reopen it in one of these other IDEs. So we'll look at that as well. So why do you want to learn Python? Again, it is a scripting language that can help you structure, document, analyze, formulate, and archive your research data efficiently, and ultimately saving you time. And so after today, I hope you'll be able to say that I know what Python can do to eventually make my research more efficient, and that I have a general understanding of the kinds of things I'm going to need to learn about Python, and then I know what an IDE is, and that I can use Python to create my own code. Python's relatively user-friendly, easy to read, easy to learn. It facilitates efficient data management, data analysis, and data processing. It's dynamic and open source as well. And again, Terra is great to have this sandbox with this great data in it. But if you're playing outside of Terra, there are options as well. So we'll look at those. So let's start with how and why Python will help you with your research. All scientific theory is data-driven. Many investigators use applications like MATLAB, and Python supports automation of routine tasks, creating efficiencies, especially when adjusting variables within that scientific method. It also supports machine learning and deep learning to look for patterns and correlations in data. And Vinay Rahu from IBM said it best when he said, the optimal approach to solving a set of problems may vary, and thus we need different tools to look at each approach. Python serves as a wonderful toolkit with which to integrate all the problem-solving tools into one container. Python gives scientists a powerful way to wrap special-purpose tools and make them easily accessible from a common application layer. So with Python, you can complete the work for your full research cycle with a single Python script. You can write your problem statement, compose your research methods, and collect your data, and then generate the results and visualization from those results to show their special or unique significance. And then write an analysis discussion of your findings and conclusion, and then generate your references, and then you click the run button and you're ready to publish. See, you're finished in 5 minutes. It's AI in a box, sort of. Maybe not quite that easy, a little bit of learning to do in between, but you get the idea. So anyway, again, with Python, your paper and your result will be set to print and submit. So, and when you think about the process that was before, you needed a Word document, an Excel document, this and that and the other, and all of that, bringing it all together. Python has the capacity to make life easier for you. So now we're going to take a look at a very high level 1,000-foot view of Python code. And our objective here is to get a flavor of the concepts you'll eventually need to understand, not to actually consume these concepts during this session. The goal is to pique your curiosity and show you what can be done so you can see how this will make data analysis and processing aspects of your research more efficient and easier to document and share. It's not to overwhelm anyone with weeks worth of information in a single hour. So here are the concepts you'll want to know: syntax, variables, functions, data types, conditionals, and libraries. So here we go. We're going to learn a little bit about them. Syntax refers to the rules in writing Python code. There are lots and lots of rules in Python. Syntax rules will stump every coder at some point, but as you learn these rules, errors are less likely to occur. There are rules for creating identifier names. Think of identifiers as nouns you need to define, and then identifiers can be assigned to variables like an X and a Y. And then there are functions. Functions are really short bits of code that perform a single task. For instance, import pandas. Classes. A class is a tool, like a template, that creates an object. It allows you to bundle data and the functionality of that data together. For instance, if we wanted to build a house, the blueprint defines the functions and the source materials list defines all the materials needed to be put in that object. So that would be a class. And class names need to be uppercase, while identifiers can be in lowercase. These are all syntax attributes you'll need to know. So then there are also some reserve words, which we'll take a look at on the next slide. And then punctuation is also important in Python. I promise you that colons will give you a headache if you let them. So whether it's a colon or a quotation or opening or closing a paren or a bracket or squiggly bracket. But what's nice about most IDEs is they'll also give you error messages. And so it's kind of easy to pick that stuff out and correct it. Once you understand the what, the why, and the where, finding those errors becomes easier and creating them becomes a lot less frequent. There are loops and if statements that must have logical indentations, specifically for spaces or a tab. Because if it's not properly indented, the code will not run. And loops are used for iterating over a sequence of if statements, or used to determine if the criteria has been met before moving on to whatever that next condition might be. You also learn to comment code, which is extremely helpful and extremely important to others using your code. Others includes your future self. If you close a package and open it up 3 months later, it's really helpful to have your own documentation there. And then comments require you using the pound sign to make those comments, and we'll see those in a few moments in the code as well. So here's an example of all of the reserved words. You don't want to assign an object to any of these words. You just need to know not to use those words. These aren't really words you would use anyway, but there are 36, I think, stop words.
Excuse me, Cynthia, just to remind people, you don't have to take notes and stuff from this. This will get posted. So you can go back and you'll have the reserved words that are there. So it's better to pay attention instead of trying to do screenshots and trying to write down the words. They're going to be available to you afterwards. So
where can I find the recording afterwards?
Again, it's on the NIMHD webpage.
Okay, thanks.
It's in the link. There's a link to it in the chat in 3 or 4 different places now.
So let's talk about variables now. Variables are containers for storing data values. Values can be a single item, such as a number or a character string or an equation or a range of numbers. A variable could be a tuple, a list or a dictionary or a data frame. We're going to talk about those things in just a second. And then a variable is created as soon as you assign it to a value. You have to use a special character in R. It's simply an equal sign in Python. So the variable can, again, be a single letter or a meaningful phrase. It's completely up to you. You decide as the coder. Then there are functions. Functions are blocks of code that perform a specific task, analysis, or maybe create parameters for you. Functions return some result, and in addition, information can be passed to other functions as an argument. Functions always start with the 3 letters def for definition, and then list the function and the parameter being called by the function. In this example, greet, the name of a function, is calling the parameter variable named, and the parameter variable named will equal whatever character string is defined by greet. So the function will print hello plus the value of named, and then it will end the sentence with an exclamation mark. So this code will produce the statement, hello, new Python coders. In a couple of months, I could change the value of the parameter named to experienced Python coders. And so the URL shown on the slide, which we'll get, will take you to a list of many functions already built into Python to be sure you can, which you should explore after the class. It makes it a very powerful program. So here are, this slide shows 3 of the 4 main data types used within Python. So we're going to talk about tuples, lists, and dictionaries. The 4th data type is called sets, but I'm going to leave that for your future learning. This again is just a sampler of Python. So tuples are ordered elements that cannot change over time. They're denoted in Python by being placed with a parenthesis. One example is found in arithmetic, for instance, the order of operations. Please excuse my dear Aunt Sally. Lists are created by placing a set or ordered values inside brackets. Lists are the most versatile data type within Python. Order doesn't necessarily matter within lists. There are examples of 3 lists, names, cities, and items. Also, items can be repeated in lists if needed. Then there are dictionaries, and we'll just talk about dictionaries briefly, but they're stored items in key valued pairs. Excuse me. So they are changeable, and they do not allow duplicates. They often store data values like a map. So note how the value names is paired with Annie and the value items is paired with apples. Excuse me. So anyway, let's talk about conditionals. Conditionals can be either loops or if statements that iterate through a sequence. So determine if the element is in a sequence. So you can determine whether an element in a sequence meets some condition. And if so, some process happens depending on the outcome of the condition. Loops and if statements are the important part of Python coding. It's where your logic occurs. Loops allow you to evaluate a range of data points against parameters. Loops will take an argument. And again, an argument is a variable that's been assigned something, a tuple, a list, or a dictionary, through a sequence until either the end of the argument or it reaches a condition where the sequence is designed to stop. If statements will check for a condition and then process that information as directed. This slide shows a simple example of each conditional. Again, the point of this information is just to make you aware that these things exist and that you'll learn them. It's really impossible to teach Python code and logic in an hour. This is just an overview. So here's an example of a data frame. Data frames are the most frequently used data structure. You can think of any table as a data frame, whether it's a .csv file from Excel or from a SQL server. You'll likely be working with these data structures the most. To do that in Python, you'll need again, we had talked about it earlier, the Python library called pandas. And pandas are fast, powerful, flexible, easy to use, open source data analysis and manipulation tool built on top of the Python programming language. It'll read your .csv or data frame into your code. And it works with other libraries to perform that statistical analysis and visualizations. We had talked about NumPy, so it often frequently works with NumPy. You import them together. In this example, first you import the pandas library, then you create an identifier or a variable called df for data frame _ alphasong, and then you set a path from your data frame to your variable to read your data into your code. And that's how your data gets to your code. It's really just that simple. And again, you don't need to worry too much about the details today. The idea is just to capture the concepts. Just to repeat that, this is really a simple process. You assign a data frame to a variable so you can read that data frame into your code. And then you perform analysis on the data within that data frame. And then again, we'll look at specific examples today.
So Cynthia,
Sure.
one of the comments in the chat is
Mm-hmm.
to define what a library is.
Sure, absolutely. So a library in Python is really just short scripts of code. They're tools, if you will. For instance, pandas will load up your data frame so that your code will understand that data frame. Now you're going to have to flesh out bits of that data frame in your code. And we'll look at an example when we get to the hands-on part, where you're going to have to define the fields within your data frame, and you may even call out specific rows within that data frame. But pandas does the heavy lifting of pulling that .csv file in from wherever you're bringing it in from, and loading it up into your Python code so that it can start looking at it and analyzing it. That's just one example of one library. But at pypy.org, and again, that is going to be available in the slides, you can go out and find hundreds of Python libraries that are already doing things. And I'll digress for just a second. For instance, when doing library work and I'm looking at bibliometrics or looking at what mesh headings are used within a particular article, I wanted to analyze how frequently specific mesh terms were used in a batch of hundreds of articles. I had a list of hundreds of articles. So I was able to use Python to separate out a specific field. Actually, it was a combination of Excel and Python, because again, I'm still a new learner myself. So I cleaned things up using Excel and maybe a little OpenRefine, but I got to a point where I had a simple data frame that I could pull in with Python. And I found out there on, this one wasn't at pypy.org. I think I found this one on GitHub, whatever. You can find them in libraries in a couple of places, but I found this library where I was able to analyze and count mesh headings, and it took me like 3 minutes once I had everything all cleaned up. But I digressed. Let's get back to the rest of the didactic for this afternoon. Hopefully that defined what a library does. So think of them as tools that will do the heavy lifting of code for you so that you don't have to do that hard work. And we're going to look at a couple of libraries. We're going to look at NumPy, we're going to look at pandas, and we're going to look at some visualization libraries as well. So anyway, I think I've described what I wanted to describe to you about data frames, but it's really straightforward and not all that difficult to learn. You just have to have a little determination to make sure you learn. So again, here, I should have waited. I had here a few examples of libraries, pandas, NumPys we've talked about. Deborah had mentioned TensorFlow earlier and scikit-learn as well. And we'll be using matplotlib and Seaborn as we do our visualizations. And so when you bring these libraries into your Python code, you simply type in a line of code that says import pandas as PD, so that you don't have to keep typing like all 6 characters of pandas. It's really just these 2 characters. And believe it seems like it's simple, and you wouldn't that typing in 6 letters isn't a heavy lift, but actually knocking this down to 2 letters is actually a very smart idea. So and you'll see why as you code. So this concludes the very brief tour of Python, and we'll take a quick look at some of the other IDEs. But again, these are kind of the big parts of Python that you'll need to know: syntax, variables, functions, data types, conditionals, and libraries. And see if there are any quick questions in the chat before we move on. Is there a difference between NumPy and PyCharm? So PyCharm is another IDE. Yeah. Oh, great. Somebody answered that already. And PyCharm, I have never used PyCharm. I understand that there can be fees associated with PyCharm, and so that's why I chose not to include it as part of my presentation. I wanted to stick, when I designed this, I designed it for people who were just looking at IDEs. I didn't know there was this great sandbox, ScHARe that was existing. So, but PyCharm is what I understand a great IDE. I'll get to playing with it eventually, but NumPy is really something that will look at perform analytics on your data, basically your numeric functions within your data. So if you wanted to add rows in your data set, or columns in your data set, or something like that, or perform some equation, NumPy is the algorithm that's working in the background to perform those functions. All right, so let's move on to just, again, take a quick look at IDEs just for your future knowledge. We won't be using any of this today. We're all in Terra today. This is just future knowledge for if
Excuse
you,
me,
yeah,
Cynthia, can
Yeah.
you explain what an IDE is?
yeah, absolutely. So an IDE is an integrated development environment. There are IDEs for R as well as for Python. So for frames, structure with your code. The 4 that I pulled together: Spider, Jupyter Lab is very similar to Jupyter Notebook. They look the same on the surface. The only difference is Jupyter Lab will allow you to tab and have several notebooks open at the same time. Very, very similar to your web browser that lets you have pages open at the same time, and you can click back and forth between them. So let's, for Google.
Excuse me, Cynthia. You're cutting, Cynthia, you're cutting in and out a lot.
Am I? Okay.
Let me just, for all the participants, will you please cut your video off?
Yeah,
And-
and you know what? And I'll do the same. Just we just got Comcast last week. I was so excited. We were on satellite network, so it shouldn't be the network issue on my end. But we're so excited because we're out in a rural area. But anyway, back to Python and Colab.
So if we keep our videos up, it sometimes helps. So
Yeah, I agree. Yeah, thank you. So this slide really is just to help you get set up with Colab once you're there. There's really not much to talk about there, that just specific instructions. This slide as well tells you exactly how to get there, what you need to do to set up. So if you choose to use Colab, that's how you can do that. If you're Anaconda is a package that if you're here at NIH and you want to have Anaconda, which is kind of the mainframe umbrella application that houses several other packages. If you're here at NIH, you need to ask your local CIT or IT department to install Anaconda for you. Excuse me, I've blocked out all of the other applications that I don't talk about in the program, just to highlight. Here's Jupyter Lab. You simply click the button and launch it. Same with SPIDER or Jupyter Notebook. Jupyter Notebook is really the most popular app IDE that people use. Here is a screenshot of SPIDER. For those of you who have experience in coding in R, it looks very much like RStudio. And it will run a PyCode. You actually need to adjust your Jupyter Notebook files to Py files, but otherwise it runs well. This is an example of what a Jupyter Notebook looks like. And again, we'll be using, Terra does a really great job of emulating the Jupyter Notebook within Terra. So we'll be using that primarily today. There are just some minor things like restarting the PyKernel and that kind of thing, which are, I think, slightly different in Terra. Here is Jupyter Lab. And as I mentioned, it's really the tab feature that makes Jupyter Lab different from Jupyter Notebook. And then the rest of the slides in my deck are really just talking about the attributes within each of these, which we're not going to cover in Terra today. So I'm just going to kind of scroll through these. They're there for your future knowledge. Here's a little exercise for your future knowledge as well. And before I conclude with the slides and move into the notebook itself,
I'm sorry,
I just
Cynthia, can you go back
Mhm.
one slide,
Sure.
another one? Keep going.
Okay.
Yeah. Could you just kind of go over these just a little bit? Because
Oh,
one of the
sure.
things I want to do is make sure that people have some understanding of the terminology.
Sure. So console, that's where the code runs. And we're going to be using a console within Terra. That's the code is already loaded up. When we open up Terra, it's going to be open to the console interface. It's the framework structure that's going to house our code. Project files. So when we open up that 10 notebook, that is actually our project file. Project file is a project that houses all of your code. So, and you may have several different notebooks for a single laboratory experiment. Maybe you have part of your project notebook for prepping your experimental data, and then another project notebook for analyzing your experiment data. For some reason, maybe that's just the way your experiment is designed. So a project file is really a single notebook of code where the console holds that notebook. Think of the project file as your papers in your notebook, and the console is the binder. For those of you that are used to having paper binder, 3-ring binders and that kind of thing. Variables are one identifier to assign something to a variable. So we saw some examples, and we'll look at that in code. X equals 3. Then there's the data view. So this is something that I don't know how to do in Terra. And Deborah, Luca, if you know how to get to a data view within Terra, that would be helpful. But in Colab, if you wanted to see that whole Excel file, if you wanted to see that whole structure of columns and rows within your data frame in your Excel file, you could do a data view and you could take a look at that. And that's very helpful when you're trying to figure out how to code, because it kind of helps you think about the strategy and how you need to pull data. Then there are plots. Plots are graphs being generated. And so we'll take a look at some plots as well. In some of the other IDEs, it will allow you to pull those plots out as images. And it will in here too, but some IDEs allow its own separate pop-out window, which just makes it easier to capture as an image file. And then history. So if you've gone and run your code and it's not working for some reason, you can go back and look at your history to make sure that all of the elements that you think you've loaded up into your active session are actually active. If they're not, then you just simply need to run that particular element to bring it into your active memory. Autocomplete. When you're using some of these IDEs like Colab and that kind of thing, and I have not done actual coding in Terra. So Luca, maybe you can let me know if this happens in Terra. But if I've already loaded an object, if I have said that X equals, well, we need something longer than X. If I have said that a variable is set to the word Python, Python equals X. If I start typing PYTH, autocomplete is going to autocomplete ON for me, and I can say, yep, that's the word I was trying to type. So if you have very long object names, it'll autocomplete for you. It'll do that for functions and processes, anything that any object that you've defined that's in your active memory, and then functions as well. And again, that'll all occur in Colab as well as Jupyter Notebooks. Debugging is if you get an error message, it'll tell you, yeah, this is wrong and it'll even sometimes give you an up caret. It'll say, and it's right here because you put a colon in and you didn't need it. So it's very helpful that way. And then Markdown, we're going to take a look at that. That's kind of the narrative that you would put around some of your code to explain to a reader what you're doing. So those are some of the IDE attributes that are in other codes. Let's see. I think with Python, we can put in graphs and results of functions and lines with string text in Jupyter Notebook, I guess. We're going to take a look at some of that. So I think when we get to that, it'll be clearer when we all see examples. So with that, I'll go ahead and just kind of close out. I do want to just point out that there are some learning resources. Google offers their own Python classes. There's Learn Python, a free Python course for beginners. This actually offers about 12 different free training options. Also, if you're here at NIH, the National Cancer Center offers starting to offer its own Python training. And then also NIAID will be offering a full Python class within their program, their course offering, their bioinformatics course offerings starting in September. So yes, and I'll actually send you the links for some of those as well. Can I no, Python is a coding, so can I differentiate between Python and SPSS? So I know that SPSS is a statistical package used for analysis. That's the most I know about it. I looked at it 15 years ago and I said, this is complex and a lot of statistics. In my PhD, Stanford PhD biostatistics, Stanford friends over here know it, but I don't. Python's a coding language.
So Python is used in cloud computing. It's a coding language. SPSS is a statistical package. Totally different.
Yes. Yep. They can be used together, I assume. But I have not done that. So
and people are putting in the chat, yes, Stata is a statistical package. SAS is a statistical package. MATLAB, they're statistical packages. Yes, you can code just like you can code in R, but it's different than Python.
Okay. All right, well, I will get you links to the National Cancer Center training program, which is different than NIAID's bioinformatics training program. They are two separate ones. And Python is data mining to help you find data. Okay, sort of, not exactly. So anyway, with that, here are some resources. Here are some books I use to learn Python as well. as well as some other references I found on the internet, some great tutorials and that kind of thing. So you have all of that for your learning. Okay, so with that, I'll go ahead and close out of the didactic session, and then let's get to the fun part.
So Cynthia, we're going to take a little break with you, and I'm gonna
Perfect.
go back to Luca
Okay,
so that he can walk people through again to get them registered, because there was some that he couldn't log on. So I want them to get caught up so that they can log on with you.
I think that's perfect. I'm going to get more water just in case I choke up again.
Okay,
All right.
good. You
Right.
can take a voice break.
All right, thanks. Bye.
Luca?
Of course. And I have prepared some slides for you, which hopefully will make it easier, for everybody to catch up. So I'm going to share my screen.
Did you get everybody registered, Luca?
Yes, I made it. 150 people.
Oh,
Just
you guys
so-
gave him blisters.
Okay. So I'm going to share my screen. And can you let me know if everyone sees my screen now?
Yes, we can.
Okay, perfect. Okay, so please run these steps with me. I have registered everyone, so now you should all be able to take them. So please go ahead and paste the address below in your browser. I'm actually gonna paste in the chat so that it's easier. Oh, sorry, I sent a direct message. Okay. Okay, should be in the chat now.
Okay, for those of you who are already logged on to the Terra webpage, already there on ScHARe, you don't have to do this. Just sit there and get a drink of water.
So if you have already created a Terra account and are already logged in, you will see this and you're good to go. If not, that means that you have not created a Terra account and you will see this page. Okay, so welcome to the Terra Community Workbench. And you can see that there is a login button at the end. So I'm going to ask you to click on that login button. Okay, so click on login. And then the next screen is going to ask you to sign in with Google. And please make sure that you're using the Gmail address that he provided us with to log in. So you should see this screen, click on sign in with Google. And let me know if I'm going too fast. But if all goes well, the next screen should be this one. So on this screen, please use the Gmail address that you gave us to log in. I'm going to give you some time to do that. Once you have put your email address there, please click on Next. And you'll be brought to this screen, which is going to ask you to input the password that is associated with your Gmail account to log in. So please do that. And when you've done that, click on Next. And you'll be brought to this screen if you're a new Terra user. Okay, so if you have already registered in the past, you won't see this. But if you haven't, this is your opportunity to create a Terra account. So you're going to input your name and last name. And your contact email, just use the same Gmail that you have been using so far. And then all you have to do is click on register. Okay, so after clicking on register, you're going to be asked to accept the Terra terms of service. So you can just click accept at the end of the page. And then you should see this welcome page next. So you're logged in into Terra. And you let me know if I have to explain this again. I'm happy to do that. So once you get
there, there's look at the chat that there's something that said the Fire Cloud org refused to connect.
Oh yeah, that's fine. That's for later, actually.
Okay.
So we're gonna get there. Sometimes when there is a large number of users, all trying to connect at the same time, we do experience some errors. That's not on our side, that's on the Terra side. Carlos, what do you mean when you say that you don't have any of those options? Oh, you mean the playground, right? Or okay, perfect. Yeah, so what I'm going to ask you to do next, Carlos, and all of you, so that you're able to access our workspace, is to use that address that you copied before, paste it again in the browser, address bar, press enter, and you should see the notebook that we are going to use for our tutorial. And speaking of errors, I wanted to let you know that it's normal, for you to possibly see this error message, because I have, just registered you. So if you register in advance, this doesn't happen. But when you just register some new users, then it takes some time for Google to sync permissions and to let you see the workspace. So if that happens, you just have to, try again in a few minutes. There's nothing we can do about that. That's on the Google side. But if all goes well, you should see this. So this is the notebook that we're going to be using today. I hope it's all clear so far. There is one last step that we need to take, but let me know if everyone is here. Everyone got here. Or I'm happy to recap the steps.
Give them a second.
Okay. Yeah, Carissa, of course, I can recap. So I'm just going to go back. Okay. Okay, so we started by pasting this address in the browser. It's in the chat. And, if you have already created a Terra account, you should be fine. You should see this. If not, this is the page that you will be presented with. And the page will ask you to create a Terra account. So all you have to do is click on login on this page. And you'll be brought to a screen where you will be asked to log in with Google. So here, please remember to use the Gmail address that you provided us with. So click on sign in with Google. In the next screen, provide your email, the usual Gmail address that you're using. And then click on next. And on this screen, input your password for that account. And again, click next. Then if you're a new Terra user, you will see this screen asking you to register for a new Terra account. So this is pretty simple. You just have to input your name, first name, last name, and contact email. You can use the same email that we have been using so far. And then you click on register. And then the next screen is going to ask you to accept the Terra terms of service. So all you have to do is click on accept at the end of the page. And then you should see this welcome page. So at this point, you can use the address that you copied and pasted before. You can do that again. You can paste it in your browser and press enter. And you should be brought to this screen, which is the notebook that we're going to use today. And I just wanted to mention that you might see this error. This is normal. It happens, unfortunately, when users have just been registered. but that's gonna take some time, and you can
For-
refresh the page.
For those of you who were already logged on, it's in the analysis tab. So you click on the analysis tab. Can you do that? Oh, you're
Yeah, of
not.
course, I can use my browser to do that. But actually, Debbie, that email address, I'm sorry, that address that I provided in the chat goes
know, but
directly to the notebook.
I'm looking at the chat, Luca. So
Okay,
it's in the analysis tab.
of
And you
course,
go down to Python 10.
yes. Okay, so
This is what people did before. Yeah.
yes,
Yeah,
that's
so
actually
you go
ordered
to
page,
the
so that it's easier to find.
analysis tab. And you're looking at number 10.
Yes. This one, Python code basics. Or the easy way to do that is to use the address that I provided.
So
Goes
you get,
directly.
it's the same thing. So you can get there two different ways.
Yeah. You can either go to the analysis tab and look for it. And this is the right one. Or you can use this address, which I'm going to paste in the chat again.
Which is pasted already in the chat.
Okay, perfect.
So now we go back to Cynthia, right?
No, actually, there's one last step that
Okay.
I have everyone to. Okay, so when you get here, click on Open on this button here. I'm gonna enlarge my screen so that you can see better. So click on Open, and you should see this screen. So this is to create your virtual computer that is going to do the calculations for you today. So you don't need to worry about anything here. Just accept the default values, scroll until the end of this, and at the end of the form there is a Create button, and I want you to click on that. And when you do that, you should see this message here, creating cloud environment. You can navigate away and return in 3-5 minutes. That is because it takes some time to create it. So maybe Cindy, you can maybe start explaining, and then, it's gonna take some time for everyone to be able to follow you.
Sure, absolutely.
Okay.
And I just wanted to mention one last thing. I said, oh, Debbie, sorry, you were saying something.
You finish what you were going to do, Luca, and before Cynthia, then I'm going to make a comment.
Okay, perfect. I just wanted to mention that, occasionally we've seen that when a large number of users try to join at the same time, there might be some errors like this, right? You see error creating cloud environment, that might happen. Or, cloud environment is in error state. I just wanted to mention that so that you do not get confused. That's normal. It's due to the fact that many users are trying to access this at the same time. You just have to wait, refresh the page and try again. That's all. I just wanted to mention that. And when it's done, all you will have to do is click on Playground Mode, this button here. Playground Mode allows you to, run all the computations, but still, you're not modifying the notebook. So this allows all of us to work together at the same time on the same notebook. So all you have to do is click on Playground Mode when the virtual computer is ready.
So you're not going to see Playground Mode until the basically. So I'm going to use the terms you used today until the library is uploaded. So once the library gets uploaded, then you'll be able to see the Playground Mode.
Yeah. So the first time when you have not created, your virtual computer, you're only going to see Open. Then you click on Open. You set up the environment, the virtual computer. When it's ready, the Playground Mode button is going to appear, and you have to click on that. And you see this message. You click on Continue here, and you're done. You'll be ready to run the notebook.
Okay, so we're going to switch now to Cynthia. I've been watching the chat. There's several of you that are behind, and some of you are not even approved on your email yet. So what I want you to do before Cynthia takes over, go to your reaction button and raise your hand. So click on raise hand. Kevin is going to put you, Kevin and Mark are going to put you in a breakout room with Luca. And he's going to try and help you problem solve whatever you're doing. And Cynthia is going to go on with the people who are already logged on and ready to go. Once you've caught up, then you can come back into the main room and come along with us. Again, you can follow along. Cynthia's going to be showing everything on the screen. It's not like you have to be doing the same thing as she's doing. The only reason we're asking you to log on to this is if you want to do some hands-on things. So again, you can just follow along and still get the same benefit. All right. So Kevin, can you put the people in the...
Yeah, we'll work on that right now.
And Luca will go with you to help you. And Cynthia's going to start taking over now again to walk you through.
I'll start with a big shout out for Luca for doing all this heavy lifting, getting everyone connected. That's huge. So thank you. And exactly as Deborah said, you're not going to miss anything if you're still getting connected. What we're doing is very simple steps. It's already pre-programmed for the most part in the notebook. And again, what I'm typing in is very simple, so you'll have all of it. And then just one other point of clarification, and that's to say that I'm with the NIH library. We serve all of NIH, so all of the NIH ICs, whereas the National Library of Medicine serves the rest of the world. I'm not with NLM, I'm with the NIH library. I wanted to make that point of clarification real quick as well. So without further ado, so this is our notebook. We're just going to do some very basic steps. Luca has uploaded 2 data sets that I used for my class when I teach for the NIH library.
Miss Cynthia, we don't see your screen.
Oh, okay. That's an important piece, and I should have asked that from go. Thank you so much for speaking up about that. All right, how about now? Can you see my screen now? I'll take a yes.
No, we don't yet. No, not yet.
No.
I don't see it either.
Okay, let's give it a minute because it's telling me that, wait a minute, nope, sorry. I've got.
Yes, ma'am. We can see now.
Terrific. Thank you very much. Thank you so much for speaking up on that one. And you're seeing this, that it's ScHARe, the workspaces, data prep, all of that.
Yes, ma'am.
Okay.
And we see your mouse moving as well.
Awesome. Perfect. Thank you very much. Okay, so here's my notebook. Here's an outline of my notebook here on the side. So this is just kind of describes what the notebook is. Remember, I was saying that you could use Markdown. This is an example of Markdown language. Notice that this is textual looking language.
Excuse me, Cynthia, just a moment.
Sure.
So when she says her notebook, you remember when we went there and Luca gave you a code, or they said go to this Python code basics? So that is a notebook. It's like a space where you have everything that you want to do already written out and already coded.
Right, exactly. Thank you, Deborah. And yes, please do. When I'm using jargon and it's not clear, please do speak up. So remember, you clicked on the 10 Python code basics. And so that opens up this particular notebook or this particular script of Python code. Now, what you can do in your notebook is, for instance, I have this title. It says data prep. So this is a section that talks about preparing the data for this particular script. And it gets a high level overview of what this script will do. And so this documentation here is put in Markdown language. Now, this is textual information describing my code. It's not the same as this is this is actually directional information buried within my code. Remember, I was saying you want to mark your code or annotate your code or you know, leave breadcrumbs, if you will, of what your code is doing, why it's doing it. It is a little bit different. This would be textual information about like this study performs an analysis on blah blah blah, whereas this is okay, upload your data, and you know, we're going to cross that data with data from another data frame or something along those lines. So here's the data set coming into the code, and so these are comments about the code, and you want to make sure you comment your code so you know you can go back and rerun it later. Luca did this. Now let's run the list command to see if the copy of the data is now in our workspace, and you can run that list so that we know the data is loaded and ready to use for this particular script. This again is just markdown language, high textual information that's part of the documentation for this particular notebook. Now we're here at code, and what I'm going to do is just create an example of code for all of us. So, and if you want, and you're ready, you can go ahead and type in with me, but if you're not, don't worry, you'll be able to do this later as well. So I'm going to create an object called string just by typing in STR, and I'm going to say string equals, I'm going to actually use the equal sign.
Hi.
Yes.
Yeah. So I think many people like we cannot edit this website. We are only read only. Should we click the playground mode?
Yes. If you click on the playground mode, I believe that will allow you to edit. But honestly, I've never used playground, so I'll be interested in feedback on that, or if anybody has expertise and knows.
Yeah,
Yes,
I
it
tried
is.
that.
You gotta hit playground mode, or else you're not part of the group.
So
So
should we hit Jupyter too? What happens if we hit Jupyter?
you should be in that screen on the Jupyter 10 notebook, which is, if you look on Cynthia's screen, you see the green line that it says dashboard, data analysis, workflows, job history, and then there's a green line. And then it says Jupyter 10 Python code basics. That is the notebook that she is in.
Okay, so
There's two ways that you get there. One, you go to the link that we have put into the chat at least 10 times. Or you go to the analysis dashboard tab at the very top up there, and you scroll down that list of, that's a list of notebooks. You scroll down that list of notebooks, and you find that notebook that says 10 Python code basic. So there's two ways you get to that.
Yes, the question is how you get in the notebook mode.
Then you hit open. Once you hit open, you have to go over to the little blue part where, you know, there looks like there's cloud stuff over there.
Exactly.
And when you open it up, at the very bottom of that, there's a little icon that says create. You have to hit that create button. You got to give it time because it's loading the notebook into your system. Once the notebook is loaded into your system, on this dashboard, another icon is going to pop up that says playground mode. Then you click on that playground mode. But it's going to take a little time because it's all this like code and information that is getting uploaded into your system. So don't go fast. Just give it a little bit. Click, and then it'll come up.
Just want to give you some feedback.
If it gives a cloud environment error,
yeah,
went over that, he said, One reason is because if you didn't register earlier and he had to just register you, Google has to link you in. So you have to, it's going to take a little bit of time. And this is why we ask you guys to register beforehand. So now you're going to have to just wait until Google can catch up. And then you just do those steps again, and you'll be able to get into the playground mode.
Okay, thank you.
So Aaron, if you're still, raise your hand, and Kevin and Mark will put you into a breakout room with Luca, and he can help you one-on-one so that Cynthia can finish with the rest. So if you're having trouble, raise your hand, and Kevin and Mark will put you in with Luca.
Luca actually suggested to just watch, and if we're still getting the error.
Okay.
Yeah.
Yep, because we can't change it with Google, right? So they have to get you into the system once we approve you.
I was wondering if you can make your codes a little bit larger to see if it's possible. Thank you.
Great question.
Each person can use their view options. If you go to the top of the screen, where it says you are viewing Cynthia Sheffield's screen, next to that is view options. Click on that, and then you can adjust the size to whatever size is most comfortable for your eyes.
You can hit full screen. See, up in the far right corner, there's a view.
And can I adjust my font inside Terra at all? Do you know? Like through
No.
view? No.
No.
Okay, thank you. Okay, good to know. All right. So we'll go ahead and continue creating this string. So I typed in STR equals, and then within quotes, hello, Think-a-Thoners. So that is, I'm creating this object called string. So I'm going to go ahead and hit enter. And notice it doesn't seem exciting or that anything has happened. I actually have an error message down. Well, it's actually looking for code that I haven't, I'm giving it a command that doesn't exist for an entity yet. So we'll get there in a second, but this is an example of error code and how you would troubleshoot it. So with this hello Think-a-Thoners, that doesn't seem like I did anything, but I'm going to type in the function print, and then I'm going to tell it to print the object string, and then just hit control return. And now below, it's giving me my result for this code. Hello Think-a-Thoners now prints out as a result from this script of code here. It's actually just really these two lines, script of code. So that's one example of just basic coding. So let's move on to example 2. And I know that line 13 is not giving away what I'm going to type in, but I'll go ahead and type it in anyway. I'm going to say x equals 4. So I'm setting the object of x equal to the value of 4. And then I'll create, no one would guess, but the value of y. And I'll create that, and I'll just say that equals the value of 2 times 5 as an example. And so now I can go ahead and just highlight and run these 2 examples, and it will give me the value and print x equals y, because it's actually running everything in the cell. And I've previously had the function print, and then said just simply print the object x and the object y. And so it printed those below hello Think-a-Thoners. So now we have written Python code. Congratulations, that you're coders already. So it's really just that simple to write a little bit of code. Now, it gets a little more complex. And so we'll go ahead and take a look at some other examples. Let's look at example 3. I'm going to just take the letter A, and I'm going to have that equal the value of 1. And I'm going to take the letter B and have that equal the value of 5. And then I'm going to say C equals, and I'm going to say A, and case matters. So lowercase a times B. Okay, and then I'm just going to say print C and control enter, and it'll give me the value for C. Okay, if I were to change 5 to 0, I could simply just rerun that, and then it would give me the value of A plus A plus A times B, which
Yes,
is
I have a
2.
question.
Yes,
A plus A is 3, is not 2, isn't it?
correct. But my dear Aunt Sally says you have to multiply A times B first, which gives you the value of 0.
Okay, that's fine. then. Thank
And so it was a little bit of a trick example. Yeah, but great question, but it was a little bit of a trick example. So thank you for asking. It was a good question. Okay, so now we'll,
Very similar question. Could you have put parentheses or some type of parameter around the equation?
you could, yes, you could. It would give you the same value. You could, and if it's wrong, it'll give you an error message. But so Python's okay with putting those parens around there.
Mhm, thanks.
Sure, you're welcome.
So should we assume then that the Python take cares of my Aunt Sally's and guide instructions, or we have to impose it?
We assume no. Yeah.
Okay.
No, we don't need to impose it. Yeah.
Okay, it's done automatically in the background.
Exactly.
Thanks.
Exactly. Yep. Absolutely. All right. So that's an example of very basic code. So let's look at one of the other data structures that we talked about, the tuple. And remember, the tuple is an ordered list. So I'm just going to create a tuple, and I'm going to call it fruit tuple, or actually fruits tuple, because it's more than one fruit. And we're just simply going to say that equals, and tuples require a parent. And it wouldn't matter whether I used a double quote or a single quote in this example. You just need to make sure that you're consistent with whatever quote you use at the front and the back of each item. And for your own coding purposes, I would just adopt a style that makes sense to you or your work group and stick with that. So now we'll just get to see me type a little bit. We'll do cantaloupes, and I am a librarian, so the fruits will be in alphabetic order. Dates, I'm not sure if they're technically a fruit. Any biologist here that might know? And then again, I want to annotate or mark up my code so that I know what this particular tuple is doing. And so I'm just going to say, create a tuple of fruits. Okay, and then control enter, and I have put that fruits tuple into my active memory. So now I can say, go ahead and print fruits tuple. And it'll print my list of fruits. Now what's nice, well, different about Python is that Python will count the items in a tuple or a list or whatever data structure you have, but it starts with 0. So apple is actually 0, bananas is 1, cantaloupes is 2, and dates is 3. If I tell Python to print fruits tuple, I can specify a specific argument. Each of these items in this tuple is an argument or a parameter or of that tuple.
Cynthia, I see what's happening here. You're typing tuple and the code title is tuple. So,
Oh, I see. I can fix it all.
So there's confusion as whether you're doing tuple or truple or
Okay.
truple.
We'll stick with tuple because that is the proper name, tuple. Thank you so much for picking up that extra R.
Yeah.
Thank you.
And the other one major thing that I want to address, that was a question in the chat. Somebody asked the question of, can you use scientific data? This is scientific data.
Yes, you can. Yeah.
So the only difference that you would do, what Cynthia is doing right now, is code that you can use on any kind of data. Scientific data simply means data you collected through science, right? Through a study.
Absolutely. Yeah.
So the only thing that changes is the variable names. So if you were doing a study, this could be the list of social determinants of health for a particular person. And instead of apples, it could be income. Instead of bananas, it can be education. Instead of cantaloupes, it can be transportation. So she is teaching you code that is used on all data, whether it's scientific data, education data, fruit data. The only thing that changes is the variable name. And that variable name is found on your data sheets that match, that tell you what you're looking for.
And also what's nice about Python is you can set terms that are meaningful to you. So if this were genetics data, perhaps you were looking at eye color genetics. And so you could say eye color and, call your tuple eye color or hair color or something along those lines as well. So.
And as a coder in other languages, I am going to recommend that you definitely use terms that you are familiar with and can easily remember, because after you do this and you come back, if it's not, you're going to be very confused.
Yes, exactly. And as I said, you also want to mark it or annotate your code as well, so that you know exactly what it's doing. It's easy to get involved in the process of coding and not annotate it, but you're doing yourself a big favor if you do mark each line. So here I printed just the whole tuple, apples, bananas, cantaloupes, and dates. But if I only wanted to call a specific element or parameter or argument from that tuple, I can do that as well. So if I wanted to just print bananas, what number would I print? What number would I put in that tuple, giving you the information that I had said before?
1.
That's right. So we'll go ahead and just put in 1, and then notice it prints bananas. Yes, and brackets are inside, and it does need to be a bracket to call that very specific parameter. Thank you for asking that. That's a good question. To call an individual argument, you need to put in that parameter. If I wanted to type in and call bananas, cantaloupes, and dates, what would I type?
Question for you, 2 and 3, but question for you.
Mm-hmm.
In your data set that you're reading from, you have a column that's titled fruits.
Mm-hmm.
And in that column, the types of fruits that you have are apples, bananas, cantaloupes, and dates.
Mm-hmm. It's a tuple. Yeah, the data structure is called a tuple. Yep.
Okay,
So
but my point being, you created a a data frame, data set in the syntax as
that's right. I
opposed
created
to
it. Yeah.
as
So
opposed to reading from your data.
that's correct. That's right. I just created it. It's just one simple data structure called a tuple. I know it's a tuple because it has parens on either
Mhm.
end, and I've set it to the value of fruits tuple. That was a value I chose.
So Cynthia, I think I know what she's asking. So there is a data set that would be behind this. That's where you're getting the different like apples, bananas, cantaloupes.
Nope. I just made it up.
Oh,
Nope.
okay.
This is not coming in from an existing data set. This is a data structure that I'm creating right here and now.
Oh, okay.
It's called a tuple. It's not coming from any existing data. I'm
Okay,
just creating it.
So
Yeah.
the other question is, can this also can this tuple be also used with numbers?
It absolutely can. It absolutely can. It could be used with genetics. It could be used, with genes and gene structures. If you had a whole list of genes, you could create a tuple with genes. You can create, for instance, if you were doing CAR T-cell replacement on the computer, not in a human, and you had a list of genes and you wanted to change that genetic code of those genes, you could create a tuple and replace it and say every time you find ACHT, change it to ATTH or something along those lines, as an example, like a search and replace, if you will. So I feel like I'm getting outside of basic material. So I'm going to kind of backpedal a little bit and go back to our example of tuples here. So what I'm going to do is to print bananas, cantaloupes, and dates. I can actually just say 1 through, and in this case, I'm going to say 1 through 3. And so this is 0, 1, 2, I'm sorry, 1 through 4. Can't count. 0, 1, 2, 3, 4. The way that Python works, you specify the spot just before the last number you put in. So when I hit enter, there it prints my list: bananas, cantaloupes, and dates. If I had changed this to 3, then it would only print the bananas and cantaloupes. If I changed it to 2, it would just print bananas. So that's one of the things that you'll learn when you learn how to code. And again, today is really just kind of putting your big toe in the water. It's not learning how to code, but so that's really what I wanted to demonstrate, this one simple data structure. We'll look at lists as well. We're going to create a list, and then and the code is sitting right here. All we need to do is basically run it. But if I were to type all of this in, I would create a new object called fruit list. And again, I'm creating this on the fly. It's printed here because I've prepped it up for this class, but I'm just creating something called the fruit list. And then I'm putting in, and this time I chose to use single quotes, apples, bananas, cantaloupes, dates, and this time I added raisins because, it's oatmeal and we put all these things in oatmeal, maybe not cantaloupe, but anyway, so here's my fruit list.
And
so
Cynthia, why did you use single quotes instead of the double?
I just chose to do it to show that you could do it the other. And again, I recommend choosing one style that works for either you or you and your work group, and sticking to it, because it's going to make your coding easier if you stick to, maybe you use single quotes for lists, and maybe you may, in this case, you know, I had the tuple in the double quotes. Maybe that helps reinforce that it's a tuple to you. You don't have to. You could use. I could have used single quotes in the tuple as well. So it's a style preference there. Just be consistent through your whole data structure. If you start with single quotes, always use single quotes. If you start with a double quote, always use a double quote in whatever data structure you're creating. So here's my fruit list: apples, bananas, cantaloupe, dates, and raisins. So I'll go ahead and create that. So I've created it. And then here I've said for each item, I stands for item, for I, in the range 0 through 5, 0, 1, 2, 3, 4. Remember, you stop right before the very last number. Print the fruit list, and notice that it prints in a list apples, bananas, cantaloupes, dates, and raisins. And the next.
Cynthia, quick question on the code. So you're only using the codes because it's string. Would you use codes if it was numbers?
Yes. It depends what you're doing with the numbers. If you're using the numbers for values, then you do not need quotes.
Right, and that's what I thought. If you're using it for values and for calculations, then you wouldn't need strings. But if you use it as a string in a string context, you probably need to use the codes.
Absolutely. Yep.
Thanks for that confirmation.
Right. Sure. Absolutely. So for I in range 0 through 5, you want to print your fruit list 1 through 4. And notice the output here is it just simply prints bananas, cantaloupes, and dates 5 times, because what has happened is for I, it has gone through here and said, okay, print fruit list 1 through 4. So 1 through 4 is bananas, cantaloupes, and dates. And so for every item, it said, okay, apples, I'm going to print bananas, cantaloupes, and dates. Bananas, I'm going to print bananas, cantaloupes, date. Cantaloupes, I'm going to print banana. You get the idea. And so it has simply printed that same string each time it iterated through that loop. Does that make sense? Okay. All right. Thank you. So yes, each fruit has its own value, right? And the value of fruit list is all of those fruits, and you can do different discrete things with those values if you choose. Or arguments. Each argument is really the correct terminology. So there are the 5 arguments within the fruit list, and you can do different things with each of those arguments if you choose. So, okay, so that is my quick lesson on very basic Python. So let me tell you what I want to do here. We're at 4:30.
I was going to say we're at 4:30, Cynthia. Is there something? I mean, there'll be some that can stay on if you want to continue.
Mm-hmm. So let me very quickly go through what the rest of this script is, and you can try it independently. So let me describe it. And
Cynthia,
then
Cynthia, just one sec. For those of you who have to log off and can't stay, it will be posted, and this section of it that she's covering right now will also be included in that post. So if you have to leave, you can get it when it's posted. If you can stay, it's probably to your benefit just to stay with us.
Okay, for those who can stay, I have some hands-on exercises for you to do. And then what we were going to do is I was going to go through some Python code that my classmate wrote. Let me demonstrate that very quickly for those that need to leave at 4:30. Notice that it is, okay. So this is in, okay, there we go. So this is in edit mode because it's blue. This is in run. there we go. That's in run mode because it's green. So I'm going to run that. I'm not sure why all of this is kind of hanging out in blue. There's my data set. It read that in. It's looking at, I've asked it to look at the head, which is the first 5 characters of that data set. And I'm not sure what's going on that it wants to stay. Oh, it's locked in edit mode. I don't want it to do that. How do can somebody tell me how to get it out of edit mode?
Cynthia, you can just run the cell. It works.
Just run it?
Yeah.
Oh, okay, thank you.
Sure.
I can't make it go green to run it though. If I just click on it and run, will that do it?
Yes, of course it will run.
Okay, great. Thank you.
Sure.
Okay, so here I'm just looking at the elements, the columns within my data frame. These are all columns within my data frame. This is the first bit of code, setting some values and printing out the total number of people who have lung cancer in this particular data set, people who do not have lung cancer. This is setting values from specific areas of the data set and defining how they'll be interpreted. This is adding up those values and just gathering some basic data for me in there. Then my classmate who was Joyce Thomas in NICHD, who actually put this together, she wanted to run some basic analysis on it to see whether groups had cancer groups had more males, cancer groups had more smokers, or cancer groups had more glyphosate non-users. So we'll go ahead and run those. And then we imported the ScHARe package, which is a visualization package. We also imported the matplotlib package, which helps and is part of the visualization package that's required. Here's the code. It's 4 simple lines of code that generates a visualization from this assessment above here. Because I was rushing a little bit, what I failed to point out and wanted to point out to all of you is that up here at the very top, to initialize this, we imported pandas as PD and imported NumPy as NP and imported the iterate tools library as well. So we were able to generate this visualization. And then this is the second visualization, the control group that Joyce created all of this. So all of that code is to show you, this is what Joyce and I learned in Python training last summer in 6 weeks. So I just wanted to show you that with some effort, you too could get to that level of skill in that period of time, if that's what you choose to do. The other piece in this script, and then again, we'll go back to hands-on, is just how quickly and easily you can create visualizations. And I'm going to run slow since this has been recorded. Again, we load up our libraries, pandas, ScHARe, matplotlib, and NumPy, so that they're all running. Here is the beginning of this iris data set to bring the data in. And this session of the training is really just to show you how easy it is to create very nice, neat looking visualizations that will tell your story. You can change it from this scatter plot to a box plot just by changing really the type of code.
Can I ask a question, please?
Sure.
Do we have access to these codes by any chance?
You absolutely do. When you log in, you'll be able to get all of this code will be right there for you to play with. And then this part of the script is actually to play with it. And I've brought in from Purdue as well as another site, just some visualizations. If you go ahead and run those, you'll see all of the different visualizations you're able to create within Python.
So all of this code is in this notebook. So it will always be there, no matter however many times you go back into ScHARe.
Yeah, so that was a really quick and dirty review of what is in this code. For those of you that need to go, I certainly understand, and you know, go ahead. I'm happy to
Cynthia, please
stay.
go ahead. We have hundreds that are staying, so.
Okay, great.
Please.
So those who need to log off, you'll see it on the recording. For those that are able to stay, I'm happy to stay as long as you're willing to stay, and everyone else here hosting is willing to stay. Here are some exercises that I've put in the notebook. You can go ahead and create your own as long as you were able to get the playground running. You can create your own cell. Just under this cell, just go above this one, and you can say insert a cell above and create a cell. And then you can start creating your own code, create a variable and assign some text to that variable. Go ahead and start playing with this and see what you're able to do. Once you've created your variable, go ahead and hit the run button. If you get an error message, see what the error is and see if you can figure out how to resolve that error. See if you can print it, type in a print command and get your, once you assign a value and print some text. If you make a mistake, see what that might be. Maybe you forgot to put it in quotes. Go ahead and go ahead and copy what is up here above. I find that a lot of coding is self-learning and looking up a lot of things. Really, I don't know any other way to code. When I first learned how to program, we used to have to type things out on a key punch machine and run it through a big mainframe. And if you created an error, you just had to keep looking through your printout. And conceptually, coding has not changed at all. It's just a whole lot easier to do it on a live machine.
So quick question for the Cynthia. You mentioned you take the courses last year in the summer 6 weeks. So yeah, what's that? That's a Python?
Sure.
Genetics or what is it?
Sure. So I was able to take something called, I was able to take a class through what's called the FAES program. I know not everyone has access to that or is able to get tuition to that.
Excuse me, Cynthia. I would rather focus on the code for this. For those of you that want to learn Python, there are lots of courses. We've also given you a few slides of where the free courses are. But I'm going to just tell you, if you Google Python, free Python courses in Google, many will pop up.
Yes, that is the truth. That is the truth.
I would prefer that you spend this time on code, Cynthia.
Absolutely. Sure. So if people have questions, I'm watching the chat. If anybody has chat. I assume there's a post feedback form.
Is there any other code that you want to cover?
So sure. Again, feel free to do these exercises at a later point. I did go through this one really quickly and briefly, the pandas, NumPy, and iterative tools, but I'll run through that one again. And again, in Terra, you want to use the run button. And just, this is actually reading in my code here. Here's my file. It's called trim data JT for Joyce Thompson. And that's the path that it's retrieving the data. And then I'm using a function called head. This is the name of my data frame, data JT, and then I'm using a function called head that will print just the first 5 rows as well as the title columns of each of my columns in my data frame. And then here it's print the data types. So it's telling me what type of data each column within that data frame is. And then here I won't go through every function because it's can be a little overwhelming. But the example that I use in my class is the code that we did up above. If you were learning how to cha-cha, that code up above would have been learning forward step to the right, cha-cha-cha, backward step to the left, cha-cha-cha. This is a little bit more. This is learning like ladies underarm turn, fifth position, open break in the cha-cha. So not really all that difficult, just a little bit, and just a little bit more complex than forward step, backward step. So again, and if you just simply run through all the logic, you're actually able to produce code just by pulling simple columns out of that data frame and doing an analysis with them, summing those codes, and it tells you how many people have lung cancer. So just that quickly using NumPy, you're able to do some analysis and assessment on the code. And then once you run it through a little more, see she's set. This is actually a list here. And she set it to gender, age group, cigarette smoking, and glyphosate use is list N, and list M is categorical data of males, younger people, smokers, and glyphosate users. So that's all generated there. And then once all of that data is collected, Joyce was able to write this code using some if-else statements to do analysis. And then finally, once that analysis was performed, she was able to pull in this is Seaborn right here. Remember, we set Seaborn as SNS and then matplotlib. And so we're using Seaborn, and this is a style called white grid, and we're asking it to generate a violin plot. And here's our x-axis. Here's the hue for the data plot. So it's saying the split equals true. So we want each of those to be 2 colors. And again, this is very fast, very high level, but to show you how quickly you can generate Python code. And then again, and I went through this very quickly before, but the iris data set, it's being pulled in here. And then these 3 graphs are the graphs that I typically demonstrate, but this here below is for all of you to play with and sample as you code. And as you go, if you're in here and you start running the data, well, actually I need to run the initial values. These sets will start generating themselves. So I'll let you explore the others. I don't want to spoil the fun. So let's see, why are you using pandas to read your file? So pandas is the library that is standard to use to bring in a data frame. And so that's why you need pandas. It's one of those libraries. It's a toolkit, if you will, to bring it in a data frame.
So if we have data like ACS, do we need to go through pandas?
You do. So you're going to have to use pandas as a tool, and you would say import pandas as PD, and then you would set your directory to whatever path that your data file is, where your data file is sitting. Can you get p-values and conference intervals for these? You can. So let me just run some of these. I'm pretty sure there's some p-values, and so okay. So here's a bar chart, but I think there's. Okay, I have an uncooperative line of code here. There we go. It's just slow. So here are some of your p-value analysis that you would be able to see.
There's a question on how to save.
To save the file, sure. So it's really just, it's actually right up here. It's the save files right over here. Or you could do file, save as. You're also able to download. So say you were here in Terra and you wanted to take it out of Terra and put it into Google Colab for some reason, then you can download and save it as a notebook right there. Or if you're planning to use Spider, you love Spider for some reason, you can save it as a Python file. But if you're planning to use it in Jupyter Notebooks or in Google Colab, you would want to save it as this .ipyndb file. Okay, let's see. Do you need to set a directory of data storage? So yes, so that was set up above. How do you connect to GitHub? That's a Luca question. I bet he can answer that. What type of cancer data are you using for some examples? That came off of Google data sets, and that's a subset of it, and it's a clean subset of it. How do you save the generated figures? So they're sitting there, you generate them with your code, and then if you wanted to do like a screenshot, you could do that. If that's answering your question, that's how you save it. ScHARe and cancer control data are sources. Okay, there you go. Thank you for answering that, Deborah. Thank you. Can we see tables instead of graphs after the analysis? The tables are above. I'm not exactly sure how you, there's a view table in Google Colab. I'm just not sure how you do it in Terra. Data sets funded by NIH on aging be added? Oh, that's a great question.
I'm
Deborah.
answering it in the chat. I'm answering them.
Okay, great. All right, terrific. Deborah, the rest of these are yours.
Thanks. I'm answering. Some of this, let me just address.
Sure.
You don't have to, there's no monthly fee to use the ScHARe platform. In fact, just like Cynthia said, we try to use libraries, everything that we possibly can on the ScHARe platform, we tried to do for free. So we don't try, if at all possible, we don't use things that charge. However, there are some things that are out of our control that charge. But for you to come into ScHARe and explore, it's totally free every month, anytime you want. If you create your own workspace and we store all the data, so that's not ever going to be a cost to you. But if you open your own workspace and you upload your own data and you start to run analyses, then cloud charges you money. However, when you open your new account, cloud gives you $300 in free credits. So it actually gets you started in this. I'm going to also suggest another option for many of you. If you're at a academic institution and you have to put in a budget for your department or for your projects, go ahead and add cloud platform cost to that budget. If you're a grantee and you are applying for NIH funding, it is totally acceptable for you to add cloud computing cost to your grant. It's also totally acceptable for you to add data scientists or Python experts to your grant. So there's many different ways to approach the cost, but as we have tried to do as much as free as possible. I hope that answered most of the questions there. Okay, Cynthia, did you have any other stuff to go over?
No, not really. Again, these are just the exercises for everyone to play with. I wanted to show everyone the variety of graphs and to think about, when and how and why you would use the different visual displays as you're designing your output. So, and that's really all I had to share with everyone.
I've got a question for Deborah relating to the data. So when we're on Terra and we're using the data sources and the data that you guys provide there, do you guys allow export of those, or it has to be done only in Terra?
For the most part, you can export it, yes.
Okay, thanks.
I have one quick question. So I have the Google Cloud using the NIH email address. For this workshop, I registered using my personal Gmail. I'm trying to ask in future, like in my coming projects, could I using the NIH email address to log in the Google Cloud, and then somehow
whatever address that you use to create your account is what you have to come back to use.
Okay.
But I can tell you, Luca probably has 10 different usernames, because as we do these exercises, he has to come up with the new name.
Okay.
So he's got probably 10 accounts on there.
That's true.
Okay.
So you can use any name you want. You can have multiple ways to get into it. You just have to use the same email that you registered at some point.
Okay. And as you say that Terra tries to offer us for free, but we need to pay to Google Cloud in order to access some data. Is that correct?
Not necessarily the data. We host the data for you when you want to run analysis. So sometimes there's minimal cost for data. I mean, it's like not even a whole penny, but the cost comes sometimes from the analytics part.
Okay, like the memory.
I can tell you in the social science types of data analytics, it doesn't cost that much. When people talk about, oh my God, the cloud is so expensive, it's because they're often running genetic data for like 3 days or 5 days.
I see.
And those can be very expensive, but the type of social science kind of work that we do, it tends not to be very expensive.
Okay, and regarding to the cost, we should get back to Google Cloud IT to evaluate the fee, right?
You will see. You don't see it here because everybody used our account, so today it's totally free for you.
Yeah.
But when you go back to setup and everything, you can use your $300 credit from Google to get started and to start to explore and set things up.
Okay.
It also requires you to use some sort of billing. It could be a credit card, it could be a PO number, anything where they can do that. But you can start using the 300 cloud credit.
Okay.
And you'll be notified before they charge your credit card or something. You're gonna use up your credits first, and they're gonna know when they expire.
Thank you so much. Thank you.
So for those of you who have a small nonprofit and no funds, Carissa, many of the things that we are trying to do on this platform, you're going to be able to do for free. And we are also getting additional funds to help people like you to do analysis that maybe you couldn't afford to do on your own. So if you want to reach out to us, then please send an email to me or Luca. Any other questions?
Just want to say thank you so much, guys.
Sure. It was my pleasure to be here. This is
So-
such a great setup.
So there, for those of you who need something from your employer, we have a certificate that is available after each Think-a-Thon. Mark or Kevin, when do those certificate parts go out? Like a week or two after?
That's not us that does the certificates.
Okay. So about a week or two afterwards, you can go to our webpage and download a certificate for your employer. Okay. I would like to personally thank Cynthia for doing this. This was on her extra time and her
It was my pleasure.
beyond
Thank
her
you.
work job to help us out here. I hope that you were able to really benefit from what she covered, because I know for us, and this is why we asked her, it was really helpful to get kind of this overview. So I hope it helped you guys as well. Again, all of this information will be posted. And Cynthia, thank you for your expertise and your willingness to help us out here. And,
Absolutely.
And
Thank you
it's
so much, Cindy. That was fantastic.
and all the work that you did to even prep for it. So thank you very much.
Oh yeah, no, it really wasn't that big of a deal. And as I said, we're all in this together. We all need to learn this data science thing and expand the knowledge together.
So for those of you that are still with us, if you could go to the Slido and fill out an evaluation, it helps us to improve these and helps us to better meet your needs. So if you could please go to Slido and fill out your evaluation, that would be very appreciated. And once you do that, you can just log off and just know that this will get posted in about a week, maybe two. And again, Cynthia, thank you.
Sure, my pleasure. It was great working with you guys.